This particular sum is trigonometry, and here they have told us what to use. We have to use the sum of angles formula, cos of a plus b, and we have to prove that cos theta is identical to, remember these three lines mean identical to 1 minus 2 sine squared half theta. Now this should look familiar to you because of this identity. So we already have memorized this one. Cos 2 theta is 1 minus 2 sine squared theta. So there is a identity like this. It can be three lines, that means identical. It's alright if you write two lines as well. Now this means if this is double, this will be half. So if I write cos 4 theta, this would be 1 minus 2 sine squared half of 4 theta is 2 theta. If I write cos 10 theta, it would be 1 minus 2 sine squared half of 10 theta is 5 theta. On the other hand, if I write cos theta 1 minus 2 sine squared half of theta is half theta, or theta by 2. So that's exactly what's been asked here. You have to prove cos theta is this. This is nothing but the double angle half angle rule that we have already done and hopefully has been memorized. So this is how it should be done. The first thing that we do is we write left hand side. Remember, that's how Euclid proved his theorem, so we have to write left hand side. This is an essential part of the sum. So we write cos theta should be written as theta by 2 plus theta by 2, so that it becomes theta. So we have to break theta down into a plus b, meaning theta by 2 plus theta by 2, so that we add it up and it becomes theta. So the formula for cos a plus b, let me write it down here as a reminder. So cos a plus b is cos a cos b plus means minus sine a sine b. This will be given, but I highly recommend that you memorize this. It will be very useful if you remember this and you can do it very quickly. So this would be cos theta by 2 cos theta by 2, remember cos a cos b, here a and b is the same, minus sine theta by 2 sine b is also the same, sine theta by 2. So cos theta by 2 into cos theta by 2 is cos squared theta by 2, minus sine theta by 2 into sine theta by 2 is sine squared theta by 2. Now we got this, but the answer has to be in sine squared only. So using the identity, sine squared theta plus cos squared theta is 1. So from here we can write cos squared theta is equals to 1 minus sine squared theta. So we can use this and change the identity, because it's all about changing the identities. We can write 1 minus sine squared theta. The theta will be the same, which is theta by 2. I use the word theta as a pronoun, so when they actually give theta by 2, so it is something you have to remember. When I say theta, I'm calling theta by 2 as theta, just a pronoun for any angle. Sine squared theta by 2. So by algebra, 1 minus sine squared theta by 2 minus sine squared theta by 2 would be 1 minus 2 sine squared theta by 2. This is sine s. So we have proved it, 1 minus 2 sine squared theta by 2. You can give a bracket, they have given a bracket. So now you write, therefore the left hand side is identical to the right hand side. You can give 3 lines. Proved. You can write a little proof here if you want to. Proved. Some people write QED, it's Latin. It was used by Euclid. In B they have given another sum. Usually they give two separate sums and they combine together for the final sum. That's what happens. So here we have to prove left hand side 1 plus sine theta minus cos theta is identical to this thing. Now notice here every single thing is half angle. So in the previous one we have already written cos theta as half angle. Now we have to write sin theta as half angle. So if you remember, this was the rule: sin 2 theta is identical to 2 sin theta cos theta. That means sin 4 theta would be identical to 2 sine. Now if this was 2 theta, this would be theta. So if this was 4 theta, this would be 2 theta half angle cos 2 theta. If it was sine 10 theta, this would be 2 sine half of 10 theta is 5 theta cos 5 theta. Now similarly, if it is sine theta, it would be 2 sine half of theta is theta by 2 and cos theta by 2. So this is how it works, pretty much the same way. So we can write 1 plus, let's break this down because we need half theta, so this would be 2 sine half angle theta by 2 cos half angle theta by 2. So using the double angle half angle formula, minus, we just proved it, we write 1 minus 2 sine squared theta by 2. So this is the first step. So for that you're getting the first mark, M1. So this is the M1 that they're giving you. So this is M1. So the next step is remove the bracket. You can write 1 plus 2 sine theta by 2 cos theta by 2 minus 1 minus into minus is plus 2 sine squared theta by 2. This thing and this thing cancels off, and you can take 2 common. You can take sine commons. If you take sine theta by 2 common, it would be cos theta by 2 plus sine theta by 2. That's how it works. So they have given brackets for this theta. Instead of writing theta by 2, they're writing half theta. That's why it might look a bit messy, or it might look a bit more complicated, but actually it's not. You can write it like this. So it has been proved. So therefore left hand side identical to right hand side. Proved. The final one, so now they have used the word hence. That means you use the 2 parts and you solve this. So this is a solving. Now solving an equation, we have done this in C2. This comes from C2, how to solve an equation. Now before we come to that, let's use the previous sum. So hence, so instead of 1 plus sine theta minus cosine theta equals to 0, so we just proved instead of that, instead of this thing, we can just write this thing. So instead of that, we will write this thing because they said hence. So 2 sine theta by 2 cos theta by 2 plus sine theta by 2. So we'll write that. So 2 sine theta by 2, so cos theta by 2 plus sine theta by 2 equals to 0. So that's what we have to do. So immediately we can break the sum into 2 parts. So for the first part, 2 sine theta by 2 equals to 0. We send everything to the other side, it becomes 0. Therefore sine theta by 2 equals to 0. Now if sine theta by 2 is equals to 0, we don't have to use the quadrant basic angle rule for solving the equation, because we need to have this memorized. So remember the quadrant. This is 0, this is 90 degree or pi by 2 in radian, this is 180 degree or pi. You should have this memorized in C3. And for 270 degree is 3 pi by 2, and 0 degree is also the same location for 360 degree, which is 2 pi. So sine 0 degree is 0, and sine 180 degree, I'm writing it in radian because this is C3 after all, is also 0. Now when they ask you the question sine of some angle equal to 0, so what can happen? It can happen 2 situations. It can be either 0 meaning 0 radian, or it can be pi radian. It can be 0 or pi, so the angle can be 0 or pi, so just write it directly. So theta is going to be, if you multiply with 2, 2 into 0 is 0, 2 into pi is 2 pi. So that's what theta is. Remember, this is C3. In C3 almost all the trigonometric sums are done in radians. That's how it is done. So let's move on for the next part. So for cos theta by 2 plus sin theta by 2 equals to 0, this part equal to 0. Now we can send this to the other side, so we can write sin theta by 2 equals to minus cos theta by 2. Then we can divide this with cos theta by 2. So sin theta by 2 divided by cos theta by 2 equals to minus 1. Remember, you're dividing this, so this will be minus 1. So what we do here now, I don't have any space, let me get back here. So it would be the identity sin by cos tan theta by 2 equals to minus 1. Now this is the time where you have to use the C2 rule for solving an equation, and the rule is solving a quadratic equation. The rule is, first you have to choose the quadrant, then you have to choose the basic angle, then you have to find the angle, and then finally you have to select your answer based on the range of x. In this particular sum, it is from 0 to 2 pi. Remember, 0 means 0 degree, 0 radian, same. 2 pi means 360 degree. And notice there is no equal to sign here. That means if your answer is 2 pi, you cannot select it, but if your answer is 0, you can include it. So previously we found 0 and 2 pi, so 2 pi will be excluded from our answer. So let's start doing the sum. The first thing we do, we have to draw this quadrant, and yes, you have to draw the quadrant. You have to draw the quadrant. So it is CAST, cast, and here everything is positive. A for all positive, here sign positive, everything else is negative. So tan would be negative here, and here only cos positive, so tan will also be negative here. So always make a mark with the horizontal line. Remember, that's the basic angle. So now we have to find the basic angle. So in quadrant, we don't care about the value 1, we just care about the positive or negative sign. So we select the quadrant. So step 1 is this one. For basic angle, so therefore the angle is theta by 2. This is arc tan, or you can write tan inverse, up to you. So arc tan 1. So here for basic angle, you don't need this negative sign, you just need the value. Remember this, for the quadrant, step 1, you don't need the value, you need the negative sign, so that you can actually select the quadrant. For the basic angle, step 2, you don't need the negative sign, you just need the value. So arc tan of 1. So arc tan is the same as writing it as, which most people are used to, tan inverse of 1, which is 45 degree. You should have it memorized. 45 degree means pi by 4. Remember, this has to be done in radian format, so you think in degrees but write in radian. So step 3, basic angle. So if this is pi by 4 and this is pi by 4, the basic angles, so here this is the second quadrant, so the angle is going to be, please remember not to break this, theta by 2. You cannot send the 2 here and write 2 into pi by 4. This is not allowed. You have to, till the end of the sum, you have to keep this as your basic angle, theta by 2. This is very, very important. You cannot break this down. So this basic angle theta, if you find the angle here in the second quadrant rule is pi minus basic angle. So this would be pi minus basic angle pi by 4. If we can do this, 4 into pi is 4 pi, minus pi is 3 pi. So this will be 3 pi by 4. And theta by 2 equals to, here in the fourth quadrant, it would be 360 degree minus the basic angle. 360 degree is 2 pi minus the basic angle is pi by 4. So this would be 4 to the 8. 8 minus pi is 7. So 7 pi by 4. So now step 3 is done. Now we have to select our answer. Now for selecting the answer, we have to find theta. Now here we have found the basic angle theta by 2, so let's check. If you multiply 2 with 3 by 4, you get 3 by 2. Now 3 by 2 pi is 1.5 pi, so it is definitely less than 2 pi. You can do this simple algebra. If you multiply this with 2, so 2 into 3 by 4, 2 and 4 cancels, becomes 3 by 2, that means 1.5 pi. 1.5 pi is definitely less than 2 pi, so we can include this as our answer. So the first thing that we found was 0, we'll include that. The next thing that we found was 3 by 2 pi, we will also include that. Here if you multiply this, it will be 7 by 2 pi. 7 by 2 means 3.5 pi. Now 3.5 pi is more than 2 pi, we cannot include it. As a matter of fact, we cannot even include 2 pi, it has to be less than 2 pi, so we cannot include that. So that's the idea. And one question that everyone asks, do we have to write this little radian symbol here, little radian symbol? No need, you don't have to bother about that, you just write this down and this is the answer.